Good morning. We're going to see the topic today as microstrip antenna or PANCH antenna. What we're going to see is here in this is basics of microstrip antenna, structure of the microstrip antenna, analysis of microstrip antenna, advantage of using microstrip antenna, limitation of microstrip antennas, and where are the microstrip antennas used. We are going to see all this today. The first one is basics of microstrip antenna. Okay, it is a metal patch placed on a dielectric material supported by a ground. I'll explain this in figure. You'll understand more detail. This is nothing but a metal patch placed on a dielectric material that is supported by a ground plane. This is easy to fabricate it on a printed circuit board. It is a most widely used antenna. For example, even in our mobile phones, mostly we use this type of antennas. And because the installation is very easy, small, and cost is less, weight is also less. So this is majorly used. So basic is it is a metal patch placed on a dielectric material and supported by a ground plane. Structure, as I told you, this is a metal patch placed on a dielectric material supported by a ground. This down part is the ground. Okay, this one is the metal microstrip patch. Okay, here this is called microstrip feed. Feed is nothing but we give input here. Electricity or current is given here. So this is called as a metal feed. Here, this is the substrate. This is the dielectric substrate. The ash color is the dielectric substrate. This is the ground. Okay. Okay. This is length width. This is the length of the microstrip antenna. This length. Okay. This is the height of the dielectric material. Okay. This is the width of the this one, width of the microstrip part, length of the microstrip patch. Okay, and this is the dielectric substrate. This is the ground. This is the height. Okay, this is the thickness. T is the thickness of the dialect of the this one microstrip antenna. Okay, here on a dielectric material, we place a metal patch. On the dielectric material, we place a metal patch. Okay, metal patch is also called as a microstrip antenna. Okay, it is to give supply to the microstrip antenna. We give microstrip lines here. This is, as I told you, microstrip lines. To give supply to the microstrip path, we give microstrip lines. Now transmission line to excite. Excite is that nothing but to provide electricity or provide to feed electric current into this. We give here. This is a microstrip feed line. Okay, the dielectric material here. It's a dielectric material. It is of concentration epsilon r. The height of the dielectric material is h, and below the dielectric material is the ground material. Okay, to find the impedance matching of the microstrip antenna, the position of the microstrip antenna is varied. I'll show you in the figure. The position of the microstrip antenna is varied to vary the impedance matching. To find the impedance matching of the microstrip antenna, the position of the microstrip lines. Yeah, the position of the microstrip line is varied. This line is varied to provide impedance matching. The length of the microstrip antenna is generally lambda by 2. Okay, this is the construction of microstrip antenna. Okay, then here the radiation. When you give current here, and this feeder line is varied, what happens? This produces radiation. Okay, our current produces applying electricity will produce radiation. The radiation from the microstrip antenna happens in the side, and very important. The radiation comes only along the width of the microstrip parts, not in the length side. Okay, when electricity is applied, that time the patch will radiate, will provide radiation. Okay, this radiation along the width of the microstrip antenna. So, as shown in the figure as shown in the figure below, this is a side beam. From if you see, this is a top view. This is a side view. If you see from the side, the radiation will be coming from the side. Okay. Then, very important, the height of the dielectric material on which this is placed. Now, the height of the dielectric material should be controlled, because this height of the material should be kept in a particular height, so that it would not affect the radiation from the dielectric material. Okay, if the height is more, the radiation is more. Okay, good. But above certain height, it will hinder the radiation. That is, it will stop the radiation from the patch. So the height is generally kept above Saturn, the height is generally kept below 0.05 lambda. Okay, if the width of the microstrip antenna is more, if the width of the microstrip antenna is more, this is more. If the width of the microstrip antenna is more, then the microstrip antenna will radiate also more. The radiation also will more. See, if this length is this width is more, then more radiation will be coming from the side. But there is no effect on the length. Only along the width, the radiation will come. Okay. Okay, analysis. And we're going to analyze. So as I told you, this is the length. The patch length is considered as L. Yeah, okay. Diagram is here. Okay, the length is considered as well. I told you the radiation will be only along the W side, that is the width side, not along the length side. The concentration of the dielectric material is epsilon. If the radiation from the W side, it does not radiate from the radiation is only from the W side and not from the length side. Length of the microstrip antenna is generally lambda by 2. The operating frequency F naught is equal to C by 2 L in the square root of for epsilon r. Okay, epsilon r is generally one for this epsilon r is generally one for free space, but if it's between spaces, then this epsilon r is can be written as epsilon effective. Okay, the electric field of the microstrip antenna is given by two equations, E theta and E phi. Here, this is the equation for E theta and E phi. That's the derivation for this. Okay, and then if in both the equation we can see that it depends on W. Yeah, it depends on W. So depending about both the equation depends on W. So I told you only width only radiation comes not along the net. So the equation also width is only expressed more. Okay, so based on the width, both the equation has the parameter W. So based on the width, the electric field also varies. So based on the width, the electric field also varies. This controls the bandwidth and also the radiation pattern. So bandwidth is directly proportional to W, and it also controls the width also controls the radiation pattern. Okay, advantage of microstrip antenna. It is, as I told you before, it can be easily printed on a circuit board. It is easy to fabricate. It is low size and low cost, and a linear and circular polarization can be easily achieved by microstrip antenna. The limitation of this is it is narrow bandwidth. The gain is only from 5 to 7 dB. The radiation happens only in the half plane. As I told you, not it happens only along the width and not on the length side. So radiation happens only on the half plane. Low power handling capacity, and there are chances of producing surface waves. Okay, these are the limitations. Where is this microstrip antenna generally used? It is used in aircraft communication, space communication, satellite communication, missile communication, and mobile communication. So this is about microstrip or patch antenna.